5, 4, 3, 2, 1. Oh, hello. Welcome to my laboratory. My name is Professor Mac, and today I'm going to be talking about Newton's third law of motion. Come join me to learn more. Newton's third law of motion. It appears a simple law, but has tremendous implications on us every day. It introduces the concept of action and reaction forces. The law explains why this rocket takes off and why I'm standing here on the floor and not falling through it. And it explains why you are able to sit watching me and why your tablet or phone is lying comfortably in your hand. So let me explain the law by studying some examples which you experience every day. First of all, the ability for us to stand on a floor without falling through it. While I'm standing here, I'm applying a force to the floor as a result of my weight. Newton's third law says that as a result of this interaction, the floor will apply an equal force on me in the opposite direction. In this case, we refer to the force I apply to the floor as the action force, and the force applied to me from the floor as the reaction force. The action and reaction forces are precisely the same magnitude, but in the opposite direction to each other. Now it is easy to get confused about the law, but there is a key element to focus on which will make it easier to understand. Let me show you. We have here a wall. When I push on the wall, applying an action force on the wall, this results in a reaction force applied to me from the wall. Now look carefully. Can you see that the action force is applied to the wall and the reaction force is applied to me? It is important to understand this. The action force and reaction forces are the same size, but are applied to different objects. I apply a force on the wall, and as a result of this interaction, there is a force from the wall applied on me. If you remember that the forces are applied to different objects, it will help you when applying Newton's third law of motion. It is also important to realise that forces are not just generated by live objects such as you and me. Inanimate objects such as the floor or the wall here generate forces. Forces result from the interaction of objects, and Newton's third law tells us that the forces appear in pairs, hence the phrase action and reaction. So what about this rocket I have here? And how do I use Newton's third law to launch it? Well, join me in my laboratory, where we will conduct a series of experiments to understand how Newton's third law of motion enables me to launch my rocket Mach 1. So you may be asking yourself, how does Newton's third law of motion enable a rocket to be launched? Well, you're going to find out. Join me in my laboratory as we conduct experiments such as ball throwing and releasing compressed gas to accelerate me in my cart. Do you know why this happens? Well, it is all to do with action and reaction forces. You will also learn how a rocket engine uses Newton's third law of motion to generate thrust to launch the rocket high into the sky.
Whether it's a lineman stuffing a running back or a safety colliding with a wide receiver, all NFL defenders have a single-minded goal: to stop the ball carrier.
The object of making a tackle is you want to get the guy down and limit the amount of yards he's able to gain, especially after contact.
When a tackle is performed correctly, it's not just a thing of defensive beauty. It's also an elegant depiction of Newton's third law of motion, sometimes called the action-reaction law.
Newton's third law says that each action or force has an equal and opposite reaction. So if I were to push against a body, that body is going to push back against me with an equal and opposite force.
An important part of Newton's third law is the concept of momentum, which in football is the mass of a player multiplied by his velocity, represented by the formula P equals mv. NFL players may not know the formula, but they're keenly aware of the role momentum plays in tackling.
It's very important to have some speed and momentum as you're going in to make that tackle. The better you're able to use that to your advantage, the better you're able to make contact and get a guy down right away.
In every collision on the football field, Newton's third law dictates that the total momentum between players must be the same before the collision as it is after the collision. This relationship is referred to as conservation of momentum.
The law of conservation momentum says that the P, the momentum before the collision, is equal to P, the momentum after the collision.
This law, represented by the formula P before equals P after, can be illustrated with a simple toy called a Newton's cradle.
In this case, we have displaced an initial sphere, and when we let it go, it has some momentum. It's mass times velocity. When it impacts the next sphere, that momentum is transferred through the middle three spheres and then passed on to the final sphere. And so because it has the same mass, it will move away with the same velocity that the first sphere impacted the middle three spheres.
Whether a tackle is successful or not, we can be certain that the same force is exerted on both players, and the total momentum before and after the collision is the same. For that, we have Newton's third law to thank.